Hello everyone, I hope you all are doing well. Today in three-dimensional geometry, we are going to discuss a very interesting shape that is sphere. If I talk about definition, the sphere is defined in a three-dimensional space. The sphere is three-dimensional solid that has surface area and volume. Just like a circle, each point of the sphere is at an equal distance from the center, which again, like the circle, is called the radius of the sphere. A sphere has only one curved surface, it has no flat surface, and because of that, it has no edges and no vertices. And if we cut the sphere through any plane for the cross-section area, then the cross-section areas of the spheres are the circles. You can see through the figure also, we have cut the sphere through a plane ACD, then we always get a circle. The real life examples of the sphere can be a basketball or a globe, etc. For analytical geometry, if you find out the general equation of the circle, then this is the general equation of the circle, where x0, y0, z0 is any random point on the circle. Distance between surface and center of the sphere is called the radius, and the distance from one point to another point on the surface of the sphere which passes through the center is called the diameter. These definitions of radius and diameter are quite similar as that of a circle. Surface area of the sphere is 4 pi r square and the volume is 4 upon 3 pi r cube. Now let's discuss a very interesting relationship in between the volumes of a cylinder and a sphere. For that, first, let's take a sphere and a cylinder of equal radius and height. Because we are talking about volumes, we should know that the area of cylinder is pi r square h, where h is the height of the cylinder and r is the radius. Now we have a cylinder and a sphere of same radius and height as well. If we try to fit this sphere into this cylinder, the sphere will occupy some part of the cylinder and some part will be remaining, and that we can evaluate on the basis of formulas. The part occupied by the sphere within the cylinder is actually 2/3 of the volume of the cylinder. That is why from formula also, the volume of the sphere is 2/3 the volume of the cylinder. Here you can see the ball is now fit into the cylinder, and because height is same and radius is also same, it is like sphere is inscribed in the cylinder. As the radius is same, so if the radius of the sphere we consider r, then we will be considering the radius of the cylinder r also. And in case of sphere, we do not consider height, but in case of cylinder, we have to consider height. Here if you see, the height of the cylinder would be equal to BD plus DC. And BD and DC both are radii of the sphere, or we can say radii of the cylinder itself, because initially we have considered that radius of both are same. So height of the cylinder would be BD plus DC, means R plus R. So H would be equal to 2R, where R is the radius of sphere or the cylinder. So in these type of situations where the radius and the height of the cylinder is same, or we can say that the sphere is inscribed in the cylinder, in that case the volume occupied by the sphere within the cylinder is always 2/3 of the volume of the cylinder, which we will be proving within the video. This comparison we can understand in one more way also, that suppose if this sphere is entirely filled with water, so that filled water is the volume of the sphere. Now, if I want to pour that water into the cylinder which is having the same height and the radius as of the sphere, so the volume occupied by this water is always 2/3 of the full volume of the cylinder. Here let's see the formulation. Volume of the sphere is 4/3 pi r cube. We have already seen through the presentation, height of cylinder is equal to 2r. We will separate 2r from the formula. Then it will become 2/3 pi r square 2r square. In place of 2r, write h. Then the value will become 2/3 pi r square h. Pi r square h is the volume of the cylinder. Hence, we can understand that why the volume of the sphere is 2/3 the volume of the cylinder. But the only condition is that radius has to be same and h is equal to 2r. And when it is possible? When the sphere is inscribed in the cylinder. So with the help of the comparisons, you can understand and remember these formula in much better way, and you can apply these formulas in the questions more efficiently. Really hope this video was helpful. Thank you so much for watching. Bye bye.